Now, we'll go to take up one more problem, the problem 32. A beam capital AD of 20 meter long, a capital AD is 20 meter long, is supported on two intermediate props at 12 meters apart, so 12 meters apart, carries a UDL of 60 kilonewton per meter run together with the concentrated loads of 300 kilonewton at the left end A and 500 kilonewton at the right end D. The props are so placed that the reaction is same at each support. Find the position of the props and draw the BMD and SFD. Also indicate the values of maximum bending moment and the shear force. So support reactions. So we need let X be the overhang on the left hand side. So also the reactions of the supports are equal. So therefore RBV will be equal to RCV. So also RBV plus RCV will be equal to 60 into 20 plus 300 plus 500. So on simplification, 2 into RBV will be equal to 2000. So therefore RBV will be equal to RCV, which is equal to 1000 kilonewton. So you have RBV will be equal to 1000, RCV will be equal to 1000 kilonewton. So taking the moments about the point A. Here, what we want to take is, it is not the taking the moments about the point A, which will be equal to 1000 into x plus 1000 into 12 plus x will be equal to 500 into 20, then plus 60 into 20 into 20 by 2. So on simplification, that is 1000 into x plus 12,000 plus 1000 into x will be equal to 10,000 plus 12,000. So 1,20,000 here. So this will be 10,000. So on simplification, 2008 will be equal to 10,000. Therefore, the value of x will be equal to 5 meters. Therefore, from this, once you have 5 meters here, so this has become 12. So then 12 plus 5 will be equal to 17, and this distance will going to be 3. So now we're going to take up the shear force diagram. SF at A will be equal to minus 300 kilonewton. SF at point B will be equal to minus 300 minus 300 minus 60 into 5 plus 1000 will be equal to plus 400 kilonewton. SF at C will be equal to 300 minus 60 into 17 plus 1000. So that means, in other words, you can take that value as plus 400 minus 60 into 12 plus 1000. So on simplification, you will going to get it as plus 680 kilonewton. Similarly, SF at the point D will be equal to, so plus 680 minus 680 into minus 60 into 3 will be equal to plus 500. So SF at D will be equal to plus 500 kilonewton. So how do I be able to write the shear force diagram? So to do that, SF at A is minus 300 kilonewton. SF at B, at the end point of B, we are going to have UDL and also the point load which is acting upwards. So SF at B, that is between A and B, minus 300 minus 60 into 5. So that will be equal to minus 600 kilonewton. That means from A to B, as you have an UDL and also there is a point load acting upwards. So we will first consider the UDL. So that means SF changes from minus 300 kilonewton to minus 600 kilonewton. That is between minus 300 minus 60 into 5. Again it becomes minus 300. So minus 300 minus 300 will be equal to minus 600. And that is due to variation in UDL of 60 kilonewton per meter for a distance of 5 meters. Then at the point B, we have a support reaction which is acting upwards, which is positive. So plus 1000 on simplification, you will going to get plus 400 kilonewton. So that means due to the point load, whatever you have, which is acting upwards from the point B, so SF changes from negative, that is 600 kilonewton, drastically, suddenly it is going to increases to plus 400 kilonewton on the positive side. That is due to the point load or the support reaction. SF between B and C will be equal to plus 400 minus 60 into 12. So that will going to become plus 400 minus 720, which will be equal to minus 320 kilonewton. So that is due to UDL between B and C. That is SF changes from plus 400 kilonewton drops to minus 320 kilonewton because due to the UDL between B and C. But at the point C we have plus 1000 kilonewton which is acting upwards. Therefore, that you are going to get it as minus 320 plus 1000 will be equal to plus 680 kilonewton, because now the SF changes from minus 320 to the positive value of 680 kilonewton because due to the point load which is acting at the point C from the up towards the upward direction. So you will going to get that point. Then SF at the point D will be equal to 680 minus 60 into 3. That will be again plus 680 minus 60 into 3. On simplification, you will going to get it as plus 500 kilonewton. Therefore, between C and D, because due to the UDL, SF drops from plus 680 kilonewton to plus 500 kilonewton. SF at the point D will also be equal to plus 500 plus minus 500. So that becomes 0 here. So this is how you will be able to get the shear force diagram, and the SFD changes it from positive sign to the negative sign at this point E. Then we will going to take up the bending moment diagram now. So that is what we have explained here. SF varies from minus 300 kilonewton to minus 600 kilonewton due linearly due to UDL, and then changes suddenly to plus 400 kilonewton because due to the point load which is acting at the point B and the support reaction. Then when you have SF varies from plus 400 to minus 320 kilonewton linearly because due to the UDL, then changes suddenly to plus 680 kilonewton due to the support reaction at the point C. Then SF varies from plus 680 to plus 500 kilonewton linearly. So that is only because due to the UDL. So now we will going to take up the bending moment diagram. So BM at A will be equal to 0. BM at B will be equal to minus 300 into X minus 60 into 5 by 2. So that means minus 300 into 5 minus 60 into 5 into 5 by 2. So on simplification, you will going to get it as minus 2250 kilonewton meter. Then BM at the point C will be equal to again minus 300 into 17, then 60 into 17 into 17 by 2, 16 into 17 into 17 by 2, and plus 1000 into 17,000 into 17 minus 5, that will be equal to 12. So that means minus 300 into 17 because from the point load which is acting from the acting to the downward direction, that is minus 300 into 17. Then you have the upward reaction. Due to that, the bending moment will going to the bending will going to be sagging. So it is positive. Plus 1000 into 12. Then minus 60 into 17 into 17 by 2. That is because due to the entire span. So that will be equal to minus 1770 kilonewton meter. So bending moment at the point D will be equal to minus 300 into 20 minus 60 into 16 into 20 into 20 by 2 plus 1000 into, so since you are taking at this point D, so that will be equal to minus 60 into 20 into 20 by 2 plus 1000 into 12 plus 3 becomes 15 plus 1000 into 15 plus 1000 into 3. So on simplification, you will going to get that value as 0. So when you plot this, you can see bending moment at the point A is 0. Bending moment at the point B will be equal to minus 2250 kilonewton meter. So bending moment at the point C will be equal to minus 1770 kilonewton meter. So from this, you will going to get the value as 0 at the bending moment at the point D. Now we have plotting of this point and this point and this point we have not plotted. So this point, this point, and this point, and this point we have plotted. Now we need to find out at what distance it will going to have the value. So once you join between A to B by means of a parabolic curve, you join between C and D by means of a parabolic curve because due to the presence of uniformly distributed load. Now what we need to find out is we need to find out the maximum bending moment. The maximum bending moment will going to occur where SFD changes its sign. So the maximum bending moment are at B, then C, B and C, and which is also at the point F. So to do that, let F be, that is instead of F we can take it here as E. Let E be at Y meters from C. Since Y meters from C, SF at E will be equal to 0. Since SF at E will be equal to 0, that is minus 300 minus 60 into X, 60 into Y plus 1000 will be equal to 0. So on simplification, the value of Y will be equal to 11.667 meters. Once you get this value, what will going to be the bending moment at that particular point? The bending moment at the point F will be equal to minus 300. So minus 300 into Y, then plus 1000 into Y minus 5, 1000 into Y minus 5 minus 60 into Y by 2. So we know the value of Y as 11.667. Substitute the value of Y in the above expression, that is minus 300 into Y means minus 300 into 11.667 minus 60 into y by 2. So that will be equal to minus 60 into 11.667 into 11.667 by 2. Then we have plus 1000 into y minus 5. That is y is 11.667 minus y. So on simplification, you will going to get the bending moment at the point F will be equal to 916.67 kilonewton meter in negative side. Now, once you get this point, you will going to get it as minus 916.67 kilonewton meter. Then join between this point, this point, this point by means of a smooth curve by using the parabolic curve. Because here also between B and C also you have a UDL. So therefore, since the UDL is there for the entire cross section, then the BMD will going to have all the lines have been joined by means of the curves because due to the presence of uniformly distributed load. So this is how you will be able to analyze and solve this problem on the simply by overhanging beam on which there will be unequal distances of overhanging between the point B and A and between C and D. So this is how you will be able to analyze the problem. Thank you.